Hi guys, so today we'll be solving this problem called longest common subsequence. Given two strings text1 and text2, return the length of the longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters can be none, deleted without changing the relative order of the remaining characters. For example, ACE is the subsequence of A, B, C, D, E. Okay. A common subsequence of two strings is a subsequence that is common to both strings. So basically, a subsequence is something which is there in the string, but it is also present in the correct order as it is in the string. So, for example, when we have a string called A, B, C, D, E, then A comes before C, comes before E. So these are in the order. Therefore, ACE will be a subsequence of of ABCDE. So you have to find the longest subsequence between the two strings. So, for example, A is here, then C is here, and then E is here. Therefore, the longest common subsequence is 3. Whereas when we have ABC, longest common subsequence is 3. And when we have ABCDEF, the longest common subsequence is 0. Because nothing is similar, nothing is same in both the strings. So text1 dot length, text2 dot length must be between 1 and 1000. Text1 and text2 consist of only lowercase English letter characters. So what we'll be doing is that we'll be, trying to find. It's a very famous DP problem. Okay, this problem is a very famous DP problem, and we know that it is going to be solved by DP. But what we'll try to do is we'll try to intuitively find a solution for this. So we'll start from recursion, and then we'll reach DP through memoization. Okay. It has been asked in a lot of companies, you can see, and so basically, it is an important question, and let's solve the question. So, what we'll do is we'll create a helper function, uh, subs, okay, where we'll be passing text1, text2, text1 dot size, text2 dot size, okay, which will be giving us the answer for text for the subsequence. And now we'll be having uh, int subs, okay, string text1 and text2 int m int n. Okay, now what we'll do is that we'll create a condition if s, okay, we'll just name it a simpler variable so that we can use it often. S2 of n minus 1. So basically, if m minus 1 and n minus 1 are same, at that time we will be returning subs s1, s2, minus 1, and minus 1. So if the strings are same for both the both the strings, so we'll be returning 1 plus the next substring that we have to find. Sorry, the subsequence which I have to find. So we'll be returning 1 plus subs. Okay. Else we'll be returning maximum of subs s1, s2, m, minus 1 n, or subs s1 s2 m n minus 1. Okay, and now we'll just check a base condition that if n is equal 0 or m is equal to 0, at that time just return 0. Okay, and let's run the code. It will give us a TLE, but this is the recursive intuition that we can create first. Okay. Hmm. Okay, so it should give us a TLE. Yeah, it gives us a TLE. So what we'll do now is that we'll try to memorize the solution. So how do we memorize that? First, we'll be creating an DP which will be storing the subsequences. Okay. Now, since two strings are changing and we have two variables which are changing, so we will create a DP of 2D size. Okay. So let's have this of size 1000 and 1001. Okay. Now we'll fill the DP with mm, we'll fill it with -1. Okay, and we'll pass it in the function. Okay. Now we have this here. Okay, and we'll try to memorize the solution. So how we'll do that is that we'll we'll create a condition where if dp of m n is not equal to -1, at that time we'll just return dp of m n. That means the dp is already there. We have the solution for that. We have already removed it, so we'll be returning the solution. Okay. If it is 0 or m is 0, at that time dp of m n is equal to 0. Okay. Otherwise, dp of m n is equal to 1 plus subs. Else, dp of m n is equal to max of subs. Okay. In this, we will be passing dp also, as well as here. Okay. And we will be returning dp of m n at the end. Okay. Let's run the code if to see if it's the memoization is working. Okay, that works. Okay, all right, cool. This works. So I hope you guys understood the intuition behind the recursive solution, and you know the steps for memoization. It's quite simple. That what we have to do is that we have to create a DP, and then we have to store the answer in that DP. And for that, we just have to simply replace every recursive, the base condition, and as well as the recursively whatever we are returning, we have to replace that with DP of mn, which is that we are storing the solution in the DP. And this is what we have to do when we are creating a DP and solving it by memoization. So it is not necessary to always solve the problem top down. It is fine if you do it with memoization, because memoization is at the end of the day DP, and the time complexity for DP as well as top-down approach as well as memoization is almost the same. So I hope you guys understood the problem. Thank you.